Okay, so welcome back. Welcome to our 16th Roses Reading Online Sports Economics Seminar event. This week is our first double header. We're really delighted to have Alex Farnell of Lancaster University and Daniel Weimar from the University of Duisburg-Essen speaking. So we'll have Alex speaking first right now for the next hour or so. He'll have about 45 minutes to speak, and then we'll have a 15-minute Q&A session. And then we'll have a second talk. We'll have Daniel's talk at 3:30 till 4:30, again, at 45 minutes with 15 minutes for Q&A. So if you want to use the chat function to ask questions, if you keep your microphones on mute during the talks, ask questions in the chat room. I'll try and field questions and then present them to Alex at the end of his talk during the Q&A session. And if there's time, we'll have a few moments of open mic Q&A as well. But without any further delay, Alex, do you want to take it away and present assessing the role of fatigue and multitasking on worker performance, evidence from MLB pictures?
Great. So let me just share slides. Is that up now?
Looks good. Do you want to try and get it on the full screen? Yep, perfect.
Yep. Great. So thanks everybody for being here today. It's a real pleasure to speak to you all. I'd also just like to say a big thanks to James, who obviously organising this Roses has been terrific. So thank you very much, James. So today we're going to be looking at the role of multitasking and fatigue and how it impacts on worker performance. And we're going to be looking at baseball pitches. So this is joint work with Dave Berry from Southern Utah, Brian Mills from Texas, and then Vincent O'Sullivan and Rob Simmons, who are both my supervisors from Lancaster. So Brian and Rob are both here, so hopefully they can see the chat window. And if you've got questions throughout, then hopefully we can put them on there, clear things up, and then that will make my life a bit easier at the end. So without further ado, kind of starting point to consider all this is that we know productivity varies over short spaces of time, and in particular it can change in response to several factors, such as what you've been doing in the build-up to that particular time. So the paper in 2004 by Hart said, he was kind of summing up various other bits of theoretical work, and said that yes, productivity isn't constant, but also it probably has some discontinuities in it over the course of a working day. And he said that fatigue could play a part. Boredom is probably what you put down as mental fatigue, but it could also be physical fatigue, for example, depending on the type of job. But basically trying to capture this relationship empirically is quite challenging. There's the well-known problems about how we measure performance accurately. Is it comparable across different workers, across different industries? And in order to track how it changes over a short space of time, we need observations on a quite frequent basis, which isn't always easy to get hold of. So what we have with baseball data is we can look at pitch level data, and this not only allows us to track how performance changes over a very short space of time, but also how it changes in response to what the pitcher has been doing up to that point in the game. So what we're proposing is that multitasking is one possible source of fatigue, and as a result then declining performance. Now most evidence that we have on multitasking comes from psychology experiments, and they suggest that we aren't particularly good at coping with multitasking. But it's not always clear how these experiments relate to what goes on in real life, because the experiments they do, I mean, I don't know how many people sit behind a desk and do Sudoku puzzles or crossword puzzles, but they're the kind of tasks that they're getting people to do. So it's not always clear how they respond exactly to real world to real world. So again, what we have using this baseball data is we can look at pitchers who are doing different tasks sequentially, and we can look at how that affects their performance on their main job, which is of course pitching. So the lit review, I apologize, it's actually quite a long lit review I've got, but I think it's important to go through all the relevant bits in detail. Starting off with how we've looked at fatigue in the past. The evidence is surprisingly quite mixed, looking at the effects of extended hours on productivity. So there are some papers that find exactly what you'd expect, which is that extra hours worked produce less to output than the previous hours worked, and that's the Penkerville one in 2015, looking at munition factory workers in World War One, where the demand for their products was largely driven by what was going on the front line. And then there was also the Collowet and Salmon paper from 2017, looking at variations in shift types from call centers in the Netherlands. There are also papers that find no effect, so each additional hour that you work contributes exactly the same to output as the previous hours, and that was the one looking at citrus root pickers in California. And then surprisingly, there are papers that find exactly the opposite effect to what you'd expect. And this interesting paper from Liu and Liu in 2017 is a diff in diff paper looking at states in the US that had banned compulsory overtime from nursing homes in some states in the US. And they actually found that in the states that had banned compulsory overtime, the quality of care actually fell. And what they put this down to wasn't necessarily workers changing their effort, but more that the care homes were employing a different mix of staff. So rather than having full-time proper contracted workers, they are moving to more of a 0 hours contract type of situation, so the workers were less skilled. It's not just productivity that fatigue can affect. There's a whole host of literature looking at the effect on workplace injuries, looking at road traffic collisions, particularly in truck drivers following extended spells driving. And the paper at the bottom there, you can see, highlights multiple industries where worker fatigue has been cited, perhaps not as the major cause of accidents, but certainly as a contributing factor. Industries like aviation, maritime, and nuclear power plants were the big ones where fatigue had contributed to accidents. As for the sports literature, there's essentially 2 or 3 different tracks where we look at how fatigue affects performance. The first of which is looking at, does having more days rest between games contribute to fatigue, and therefore how does it affect your performance? The first paper looking at the NBA would suggest that the more days rest that traveling teams have in between successive away games actually helps them out. Teams who have fewer days rest between successive away games, that contributes to home court advantage. The evidence from the Scopa 2013 paper is a bit less clear. The effect has kind of been changing over time. I think pre the Italia 90 World Cup, there was something going on, but as sports science and as knowledge about how players recovered between matches got better, that difference was wiped out. And then the other strand of literature really looks at travel time and travel distances and whether that matters for performance. But to get at what goes on within a particular game, which is what we're interested in, you really have to go to the sports medicine, sports analytics literature. So there's a bit of stuff on Serie A, which is the Italian top division, looking at if players do more in the first half, then how does that affect not only their physical but their technical performance in the second half of games. And then there's some stuff from baseball as well. So the Lyman paper gets pictures in a sports hall and hooks them up to various video sensing technology, and they see that there's a drop in velocity between first and last inning pitched, and there's also changes to their pitching motion, so particularly the position of their back and also shoulder and elbow rotation. And the paper at the bottom, the one by Murray, looks at youth pitchers progressing from high school to college and finds that high pitch counts are associated with elbow and shoulder pain. As for multitasking, actually the effects, at least theoretically, are ambiguous and they could go either way. And they were summed up quite nicely by the paper by Arrell et al. In 2012. So on the one hand, it could be that doing the same thing over and over again, we become specialized at that, and that helps our productivity improve. But on the other hand, it could be doing the same thing over and over again gets quite repetitive, and we get bored of doing that. Perhaps the main argument as for this ambiguity, though, comes from the fact that we know workload doesn't come at us at a constant rate. There are times where we have a lot to do, and there are times where we have not very much to do. So having that effective ability to multitask could help us smooth out that output. But something that's been identified in the psychology literature is this thing called cognitive bottlenecks, which is that we don't necessarily have the mental capacity to be able to constantly switch between doing different tasks, which would hamper our productivity when we multitask. So as I said, what most of the psychology literature says is that we tend to struggle with multitasks. Although, interestingly, they do also find that there's no differences between male and female ability to multitask, which against conventional wisdom. As for industry-specific evidence about multitasking, they all find some degree of non-linearity. So up to a point, multitasking can actually be beneficial to our performance, certainly as these three papers would suggest. But after that point, then our ability to multitask declines. The one that best illustrates it is the bottom one by Singh in 2014. And they find up to a value of about 4 or 5 patients per hour in an emergency department in a particular hospital. Doctors can deal with that level of multitasking, but after 4 or 5 patients per hour, then they start to either miss diagnoses or they treat the wrong thing, treat the wrong ailment. So literature review over. So what we're doing in this paper is we're looking at baseball, in particular MLB. So baseball has 30 teams, and they are split 15 into the American League, 15 into the National League. So these two leagues they're virtually identical. The rules and regulations are almost the same, but there's one key difference here, and that's crucial to our understanding of multitasking. So in particular, the American League operates under the designated hitter rule, and what the designated hitter rule allows is that for teams in the AL, they can nominate a player called the DH, the designated hitter, to fill in the batting order in place of the pitcher. Whereas in National League games, pitchers both have to pitch, which is their main job, and then they also have to do this kind of nuisance thing on the side, which is batting and trying to run bases. So it's been this way. I think 1973 was when the AL first brought in the designated hitter, and despite speculation, mainly from the media, it has to be said, the NL has so far resisted moves to harmonise the rules. I think the last kind of meaningful debate or last meaningful vote was in the early 80s. Though it should be said that that the NL has approved the use of the DH for the 2020 season, which starts next week, I think, and that's to help pitchers in this kind of odd season that's going on, help them with the demands and try and reduce their fatigue. So I guess something similar to what we're seeing introduced in football, which is the use of 5 substitutes, drinks, breaks, and so on. So similar kind of idea. It should also be said that the NL is actually quite rare in the sense that we see pitchers batting. The only other professional league that I know of that has this kind of dual tasking going on is one of the leagues in Japan. So the NL is actually quite rare. Before we go on, I should just be a little bit more specific, because technically what we don't have here is multitasking. Actually, what we have is task switching, and there is a subtle difference. So whereas multitasking is doing jobs at the same time, task switching is doing jobs sequentially. And there was a paper in 2012 in behavioral economics that identified differences in how we perform when we're multitasking or task switching. So how we define task switching in baseball is we're identifying pitchers who have previously been batting and or running bases. And there are 2 ways in which we can define this. First of all, we can look at any point in the game up to the current pitch. But the problem with defining it that way is that, say you're pitching in the 6th inning and the last time you were batting was in the 3rd inning, is that going to really make a difference to your performance? Probably not. So a slightly cleaner definition is we use previously at bat, previously on base in the previous inning. And so that will give us a much more immediate effect of the effect of task switching. So the identification comes here because in the AL, we're not seeing pitchers doing this task switching, but in the NL, we're seeing pitchers having to do both jobs. Now, we're kind of assuming here that pitchers are randomly allocated to these 2 leagues, or in other words, they're randomly affected by this rule. Now, at first it sounds a bit of a stretch, but we're pretty confident that is a reasonable assumption to make, because we think that teams are only hiring pitchers based on their ability to pitch and not on anything else. So we don't think that teams are hiring based on the ability to bat, for example, and that makes us confident that the use of the DH rule is okay to use. We know there are exceptions, of course, there are caveats to this, but in the main we're happy to be using it. So the data that we have, we use the last 3 full seasons, so 2017 through to 2019, and we use regular season games. The data was there before, but the way that they were tracking velocity between 16 and 17 changed slightly, so we just used the cutoff of 17. And all the data is captured by StatCast, which is this system of radars and cameras in the ballparks. So this gives us about 2.1, 2.2 million pitches, I think. But what we do is we restrict analysis to starting pitches, primarily because relief pitches and closing pitches rarely get a chance to bat or run bases. So once we restrict to starting pitches, it reduces the sample down to about 1.3 million. And then for each of these pitches, we've got information about the attributes of the pitch, so how fast it was, where it was, details about the game, who was standing in which position on the field, what the score was, etc. So really rich data to work with. As for how we go and identify pitch performance, first of all, what we need is a measure that is batter independent, or as batter independent as possible, because what we don't want to be doing is confusing the fatigue and or performance of the batter with that of the pitcher. So there are a couple of possibilities we can look at. The most obvious one is probably pitch velocity, so how hard the pitcher can throw the ball. And then our preferred specifications rely on fastballs, because velocity doesn't just have an effort story behind it, but it also has a strategic element behind it, because you might be throwing fastball, 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 and then you'll suddenly throw a slower ball, and the aim is to try and deceive the batter or throw the batter off. And that decline in velocity isn't due to any effort, it's just due to a strategic element. Then we've got a couple of measures that are linked to location. First of all, we look at distance from the center of the strike zone, and you can see how the strike zone is defined from the figure at the bottom. So we know the horizontal vertical coordinates at which it passes the home plate, and so we can just calculate the distance from the center of the strike zone. We've also got a binary variable which is strike, so whether it goes through the strike zone, and then we restrict that definition further, and we use edge pitches and corner pitches. An edge pitch is anything that's in within 1.5 inches either side. 1.5 inches is the radius of the baseball, and corner pitches are those that are right in the corners. But just to save showing you endless regression tables today, I'm just going to focus on the first three, and we'll the edge pitches, corner pitches. If you want the results, I can send them after. So the descriptives. Top table is looking at all pitches. Bottom panel restricts to fastballs. You can see the difference in velocity. It's about 88 for all pitches, close to 92.5 for fastballs. We measure pitch count cumulatively at both the game level and the inning level. And you can see there 46 is the average for the pitch count in the game. It's down at 9 for the cumulative inning pitch count. The point at which pitches are replaced, you can see here game pitch count at replacement, that's just below 90. So about 90 pitches is the point at which starting pitches are pulled. As for the task switching variables, for previously at bat, at any point in the game it's up at about 31%, whereas we restrict that to the previous inning, it's down at 23%. For previously on base, it's about 7% for the whole game, and about 4% for the previous inning. So the methodology here, quite straightforward. What we're essentially setting up is a diff and diff, and we're comparing performance pre and post being at bat or on base. So performance is one of the measures we mentioned earlier. And pitch, that's the cumulative pitch count. And as I said, we run specifications looking at both the game and the inning cumulative pitch count. It turns out that using the inning pitch count is actually a lot easier to work with because it's not correlated with a lot of control variables that we want to add in. The previously at bat, previously on base, they're the task switching binary variables. And as I said, we can look at that over the entire game, or we can just restrict it to the previous half inning. Then we can interact the binary variables with the pitch count, and that will help tell, is there any recovery effect going on? Is it just a one-time effect, or does it get worse over time? In the controls, we've got inning dummies, and we also control for the current batting team score and the fielding team score, in case there's any effect of feeling the pressure of being behind or easing off when you're being ahead, for example. Then we can add in pitch fixed effects, month fixed effects, just in case there's any general end of season fatigue. Might also capture variations in temperature, and ballpark fixed effects. We know that that pitches can vary slightly depending on ballpark. So we start off the results with velocity. And velocity here we measure at the point of release. So there are various points over the course of the pitch which you can measure velocity, but we use the point of release. And in the table here, as we move from left to right, we're getting closer to the preferred specifications. First of all, the effective pitch count, the linear term, negative, and then we've got a squared term, a positive coefficient on the square term. They look like significant zeros, but it's just that they're really tiny. To 3 decimal places, they just look like significant zeros, but they are bigger than 0. So the turning points for those is somewhere between 75 and 78 pitches. So if you remember from the descriptives, the point at which pitches were pulled was about 90 pitches. So it seems that's happening just after the point at which pitches are bottoming out on their velocity. As for the task switching, the evidence here is a bit confusing, so I'll go through some more regressions in a sec just to clear up what's going on. But the preferred specifications here using fastballs and looking at the task switching in the previous inning seems to suggest that actually following previously batting in the previous inning, there is a positive effect on your velocity with some negative effect from the interaction term. There's no additional effect of being on base in the previous inning, so it's just coming from previously batting in the previous inning. So to clear, hopefully, one or two of those things up, what we do is instead of looking at the game pitch count, we look at the inning pitch count. And the evidence here is actually a lot clearer. So previously batting in the previous inning is now associated with somewhere between 0.06 and 0.27 of an increase in velocity. This is in miles per hour. And again, the interaction with pitch count is negative. So depending on specification, it takes somewhere between, I think, 11 and 27, 28 pitches in order for those two effects to cancel each other out and get back to kind of trend velocity. Again, you can see there's no additional effect of being on base. The effect here just coming from being at bat. It's also interesting just to look at the controls that we add in for batting and fielding team score. So batting team score, if the opposition has more points on the board, then it seems to suggest that velocity is declining. So maybe that would be consistent with the argument of feeling the pressure if you're behind. Whereas the fielding team score, the velocity coefficients there, you can see are positive, which would maybe suggest that you're easing off a little bit if your team is ahead, or you're feeling less pressure, and that allows you to pitch more freely, perhaps. I just want to skip to show you the. This is just a plot of one of the inning, some of the inning coefficients from one of the previous regressions. So what we've got is the velocity compared to the first inning pitched. Rather a strange relationship at first viewing. So you can see velocity seems to decline up to about inning 6, which is probably when you'd start to see starting pitches replaced. But then it appears that velocity is increasing again as we get to 7, 8, and 9. But what we suspect this is coming from is just that pitchers who are either more able to deal with fatigue or who are pitching better throughout the game are just being observed later in the data. So we are aware that there is perhaps a selection issue going on here in terms of who we are observing later on in the data, and that's something that we're going to be looking to address as we move forward with this paper. Nevertheless, how can we explain this increase in velocity? I have to admit, when I first saw those results, I was a bit shocked. I thought we would get a negative coefficient, but then again, I don't really know that much about baseball, so I don't know why I was surprised. But then, I suppose, in line with a lot of previous literature, they actually find that some task switching is beneficial to performance, so perhaps we shouldn't be that surprised that we're seeing an increase in velocity. As for how we can explain this in a baseball game, it could just be that the mental break of having to bat helps refocus your mind back on pitching. Perhaps if you've made a mistake in your last inning that you were pitching, it just gives you less time to dwell on any mistakes. It could also be a physical argument. So, I don't know, you've been pitching for a couple of innings. You might be sitting on the sidelines feeling that your shoulder is stiffening up, but then you go to bat and it might just help you to loosen up that shoulder, for example. So there's a couple of arguments as to why we're seeing the positive effect. And there's also the less kind of fun explanation, which is, as I mentioned, we've got the selection problem, but that's something that we are looking to address as we go forward. So next onto location results. So this is distance from the center of the strike zone. You can see the effective pitch count is positive, although the magnitudes are quite small. Distance is measured in feet. So you can see as you add in more pitches, you're getting further away from the center of the strike zone. So that could either be good or bad news, depending on exactly how far away you are. We just need another regression that I'll show you in a sec to clear that up. As for the effects of task switching, the effects of previously being at bat, whether we look at the previous inning or across the entire game, the effects are pretty similar. And you can see that post being at bat, you're getting closer to the center of the strike zone, which is a worse quality pitch because it makes it easier for the batter to get a contact with. Again, not really much additional effect of being on base. There is a bit of significance going on in specification 2, but overall there doesn't really seem to be much additional effect of being on base. So we need to clear up the effect of pitch count. Here we've just got the binary outcome of whether or not you're throwing a strike, and you can see the effect of pitch count there is negative. So yes, you're getting further away from the center of the strike zone, but that's coming from the fact that you're throwing fewer strikes, not because you're throwing better strikes. The positive coefficient here on previously at bat, that's expected because we showed it in the previous regression that you're getting closer to the center of the strike zone. So yes, you're throwing more strikes, but they're worse strikes. So the final bit of analysis I want to offer you is slightly moving away from the within game stuff, and we're looking at what the effect would be if you suddenly experienced an increase in workload, and that increase in workload is batting and/or running bases. So it could be that this sudden increase in workload makes you more susceptible to drops in performance, rather than it could just be something that you're used to if you've been doing it for a long time. So we restrict analysis to the National League, and remember the National League is the one that doesn't have the designated hitter rule in, so you're having to task switch. And what we do is we compare the performance of what we'll call established NL pitchers, and these are guys who've been in pitching for a while in the NL, to people who've recently transferred across from the AL. So these are the guys who are suddenly experiencing this increase in workload. So we compare their performance in the first 10 games and the first 20 games. These switches are actually quite common. Over the 3-year period, there were 746 pitchers who changed teams, and 186 of these were people who switched from the AL to the NL. As a robustness check here, what we also need to do, because if you change teams, what you're also doing is changing your working environment, and it's not just a case of having more stuff to do. So to try and filter out some of that effect, what we also do is compare pitchers who've moved from one NL team to another NL team. So these have got essentially the same workload, and we compare their performance to what happens as a switch from an AL to an NL team. The results, the first 4 rows are essentially what we've seen before. So again, we've got this positive effect of being previously at bat. You can see that switching from the AL to the NL is associated with a decline in velocity, as is the switch from NL to NL, though the switching from AL to NL is a much bigger coefficient. So there does seem to be some kind of general change of workplace, change of work environment going on, but the effect is bigger for the switch from AL to NL. What's more interesting is if we look at the interaction with the previously being on base. So this is on base now, not previously at bat, which is where the significance was coming from before. Actually switching from the AL to the NL, following previously being on base in the previous inning, is associated with a drop in velocity of about 0.35 of a mile an hour, whereas that same significance doesn't exist if you've recently switched over from one NL team to another NL team. So yeah, even though there is some general change of scenery effect going on, it seems that there is some additional effect going on from having to suddenly increase your workload, shown by the AL to NL interaction with previously on base. So I'm actually pretty much done. I'll open up to questions, but just to quickly conclude. So what we've been doing is we've been using pitch level data to examine the effects of how previous workload affects what your current performance is. And much in line with a lot of the literature on task switching, the evidence is actually quite mixed. So perhaps up to a point, some task switching could be beneficial. We've shown that there are benefits to velocity following previously being at bat, but the effects on location seem to be working in the other direction. And then the final bit of analysis was just looking at pitchers who switch leagues, so exposing them to a sudden increase in workload, and that does seem to have some detrimental effect on performance. And with that, I'll hand back to James and look forward to comments, questions, etc.
Okay, thanks very much, Alex. It's actually been quite a quiet day on the chat room. Those who are unable to use the chat are always welcome to drop me an email if they've got particular comments they want to make. The only comment in there is from Brian Blank, who says, one way to assess if pitchers are randomly allocated between leagues may be to look at the batting performance of AL pitchers when playing in NL parks compared to NL pitchers. To the extent that they're randomly allocated, you may expect batting averages and performance to be similar. I think you could also look at instances where they're likely to be more random, e.g. when the Astros switched leagues in 2013 or when pitchers are traded across leagues at their trade deadline, and pitching talent may be limited.
Yeah, interesting point. So that would be, the first part of that would be interleague games, is that right?
Yeah, it looks like it. On particular parts, yeah.
Yeah, that's an interesting point. I think there's certainly stuff we could look at there. Yeah, I think probably to be more convincing on that rather than just making an assumption, there probably is something we could add in. Yeah, we can look into that. Thank you very much.
And then Dennis writes, except for this last bit, can't the whole thing also be done on hitters? Greater likelihood of errors or some kind of mistake after a player has been on the bases in the inning before? Probably. Yeah, I might have to ask either Rob or Brian to come in on that one, as my baseball knowledge isn't particularly good beyond pitches. But yeah, I guess we could. I'm not sure. Right. Yes.
Just right.
So the implication is that batting could impact fielding. Is that the question we're on here from Dennis?
Yeah, basically, I mean, the story that you're telling, I think, is that there's a difference in pitcher performance after the pitcher was at bat or running the bases. And
Right.
why does that have to be limited to pitchers? I understand the difference between the leagues because the designated hitter gives you a different kind of a comparison, but all players sit on the bench in the, when they're on offense as opposed to out in the field. And so there's a switching as opposed to multitasking going on for every player that's in the game. And I
think that's a good point. I think, as you mentioned, when we originally talked about this, the impetus was the ability to get a sort of difference in difference estimate with the AL and NL differences. But I guess my other point, and Alex is more familiar with this literature on multitasking and task switching. But the two things may be more a part of that job because they do it so much more. And so my thought is this really strange sort of nuisance task for the pitchers might be something that we'd expect to see more of an effect going on. But I think it's a good point that this could be happening elsewhere for sure. Yeah.
Yeah.
When I was writing it, the other thing that occurred to me is that maybe there's not sufficient defensive metrics like pitch count or like pitch velocity or location. The vast majority of the time, the outfielders are standing there with, their hands on their hips. And
yeah, and we know errors, right, are not a great measure either.
yeah,
Particularly with the way positioning is changing over this time. And the other nice thing about pitchers is we have the underlying skill changes rather than just the outcome changes. And so those are a nice, useful measure of performance where we know there's a lot of randomness in baseball that can really mess with the outcome measures as well. Although I think Dave suggested that we should start moving into looking at those outcome measures as well.
Yeah. Yeah.
thanks.
Thanks, Dennis. Thank you.
Okay, Zach Phone has also asked, could pitchers batting lead to an increase in adrenaline? Perhaps that could lead to an increase in velocity.
Yeah, I guess so. I guess certainly if you get a good outcome, maybe it's the buzz of getting to bases, because it happens so rarely for pitchers. Perhaps it could be. It could be. I think we'd have to dig deeper into what's going on there to explain it. But yeah, I would buy that as an argument. Yeah.
Stefan's got his hand up.
Hi there. So my thought is, have you thought about looking at interleague play? Since if it's the case that pitchers get tired out or underperform when they're because they have this additional task of batting, then we have a sort of control for that when we have interleague play when you're playing with either designated hitter rule or not. So we should see some difference in the results of games in interleague play depending because of this effect. And there's large numbers of interleague games, so
Yeah.
you ought to be able to detect that effect if you look at that if you look at interleague play.
Yeah, it's a very good point. I actually did do some analysis on interleague games. Not necessarily, well, the outcome wasn't performance. The outcome was we were looking at whether it affected injuries following batting, although I've kind of dropped the injury stuff. But yeah, I don't see any reason why we couldn't use the interleague analysis to look at the effect of the workload argument when you're suddenly exposed to this when the DH isn't in place for IL games in the NL ballpark. Yeah, I think that could be something we could do. Yeah, thank you, Stefan.
Okay, and then another question in the chat is, why have you chosen exactly baseball and not some other kind of sport for your research?
Baseball has amazing data. I was amazed how good the data for baseball was. I mean, I was trying to think of other sports where you could look at this kind of thing. I suppose cricket would have some similar argument, although I actually find cricket more dull than baseball to watch. But I mean, yeah.
Things
Sorry?
like that. You might have people saying things like that.
Yeah. I actually, since doing this, I've actually started to watch a few more baseball games. Yeah, I mean, I suppose there are elements of footballers having to do this, having to constantly switch between attacking and defending. I suppose that happens on a much more frequent basis. I guess rugby as well would have some similar arguments. But yeah, primarily because the data was superb for baseball is why we chose it.
Yeah, I think that must be it, because the examples you're mentioning there, you wouldn't really have much clear data on the switch between attacking and defensive play in lots of those kinds of sports.
Yeah, that's it. And the roles are quite blurred, I suppose, nowadays. Look at attacking fullbacks. A lot of them doing more attacking than defending. So yeah, it's quite blurred. But yeah, I think the story of different tasks is quite clear here when we're looking at pitching, switching between batting, running bases.
Dennis has asked, is there a control for days between the starts?
We could add it in. That would be quite an easy one to add in. Yeah, I suppose if you've got more rest days in between, then yeah, perhaps you've got more time to recover. Yeah, that would we can add that in. Have a look.
Well, that's all it is in terms of questions at the moment. If anybody else has any questions they want to ask, feel free to unmute yourselves and ask questions. We can have a general discussion. We've got quite a bit of time. We've got 19 minutes until the next talk begins, so plenty of time to have an open discussion.
Well, I don't have a question, but two suggestions with respect to the literature. There's a very nice paper by Andrea Ichino who uses data from Italian judges, and he finds that judges who concentrate on a particular case and who reduce their workload case after case are far more productive than those who work on different cases simultaneously. And this is clearly evidence that multitasking is detrimental to an individual's performance. And the second paper is by a group of psychologists. If you send me an email, I'll send you the paper. I forgot the names of the authors. What they did, they asked people to group tasks to jobs. And the vast majority of the people grouped together tasks that are very similar. And they interpret this as evidence for distaste of job enrichment, job enlargement, or multitasking.
Okay. Yeah, they both sound very good. Thanks. I'll send you an email to get the names, links. Thank you.
Any more questions, comments? Well, in which case, I guess we've got a little bit of time between now and the next talk. But before that, thank you very much, Alex, for a really good talk, really interesting talk. Good bit of research, well conducted, and a really interesting talk. So thank you very much for that.
Thank you everybody for the comments as well. Much appreciated.
So